Hi, my name is Redo Meyer, and I'm the tech lead for Google's Android Developer Relations team. In order to minimize the battery drain associated with data transfers, it's good practice to use the big cookie model to batch and bundle transfers using sync adapters and eliminate unnecessary polling with Google Cloud Messaging. Having moved all of your transfers into as few batches as possible, this DevByte will look at ways to reduce the overall size of the cookie. That is, to transfer as little data as possible and drain as little battery as possible each time we do have to do a transfer. The most fundamental way to reduce your downloads is to download only what you need. Start by using REST APIs that let you perform filtering on the server using parameters that allow you to indicate when your last update occurred or what the last items you received were. This ensures that you only end up downloading new stuff. Similarly, it's good practice to reduce bandwidth by performing any operations likely to shrink the size of your payload on the server. Techniques like gzip compression are one solution, as is server-side reduction of image sizes. Why download a wallpaper only to shrink it into a thumbnail? It's also generally more efficient to maximize your utilization of network connections, so rather than creating multiple simultaneous connections to download data or chaining multiple consecutive GET requests, where possible you should bundle these requests into a single GET. When it comes to cell radio transfers, a bazooka is more efficient than a shotgun. It's also best practice to reuse existing network connections rather than initiating new ones. Reusing connections also allows the network to more intelligently react to congestion and related network data issues. Wireless radios need to be active to transmit the termination and termination acknowledgement packets associated with server and client timeouts, so it's also good practice to close your connections when they aren't in use rather than waiting for these timeouts to extinguish by themselves. That said, closing a connection too early can prevent it from being reused, which then requires additional overhead for establishing a new connection. A useful compromise is to not close the connection immediately, but to still close it before the inherent timeout expires. Finally, cache aggressively. You can maintain a cache in shared storage within the external cache directory, or manage a smaller cache in your application sandbox. Anything stored in the external cache can be deleted by the system if it's running low on space, whereas you're responsible for managing the data stored in your application cache. In a lot of cases, you can determine when you should perform your next update by inspecting the HTTP response headers of your downloads. This is particularly useful for static or almost static resources like images. Looking at the header response, you can determine the time the downloaded data was changed and when it will expire, allowing you to schedule your cache refreshes accordingly. To make your life easier, Android 4.0 introduced a HTTP response cache to the HTTP URL connection class that handles this caching for you, inspecting headers and contacting the server only when the cache has expired or data doesn't exist locally. Throughout this series of DevBytes on efficient data transfers, we've explored how the cell radio works and how its state machine can affect the battery efficiency of your apps. Armed with that knowledge, you learn to analyze your network traffic and use techniques like prefetching, batching, and bundling, supported by sync adapters and Google Cloud Messaging, to make your apps more efficient.